Welcome to Click Academic. This is lesson number 3 on the series of set and logic theory, which inshallah will be discussing on logic. In our last class, we'll be able to discuss about some of the operatives such as conjunction, disjunction, and today we are going to talk about exclusive or and if possible implicative. Now when we say exclusive or, we say exclusive or. Now it's represented or denoted by this. This is a statement that normally comes into what? In the form of either. So therefore, how can we know whether a statement is exclusive or not? So let's take example. Let's say either Omar is a student or John is a governor. You see, we have either and or. So this statement is trying to tell us that, remember we let this to be P and the other one is what? Q. Now what connects in between? We have either or. It means exclusive or. Therefore we denote it by this symbol. This is what it means. So now, how can we, what is exclusive or is saying? Now what is the truth value of this statement? Under this exclusive or is say that this statement is true if both the statement differed. But if they are the same, it's false. Let's say, when P is true, exclusive or and Q is true, you now say therefore is false. Why? Because they are true. Then another case, when P is true, exclusive or Q is false, you now say therefore is true. Why? Because they differ. True, false is true. On the case of exclusive or. Then you now say, what about if we have P is false and Q is what? True. The same thing it applies is true. Why? Because they differ. Then in the case of if they are all false, exclusive, you now say this one is also false. Why? Because they are the same. Remember that true is false and false is false. Meaning it can be true. The statement will be true if at least one statement is true, but not both. So now let's use a truth table to see an example using truth table. Let's say we have a truth table like this. Say we have P, Q, and let's say P exclusive Q. This is true, false. Let's say we have Q exclusive P. Then this is what? True, false. Remember, we see that at least, now this one is, they are all true, and based on this it will be what? False. Then true, false, based on this it will be what? True. False, true, based on this it will be what? True. False, based on this it will be what? False. That's the first aspect. Then this to check whether it's commutative or not. We now say, true is what? False. False, true is what? True. True, false is what? True. False is what? False. Now you see that what is in here is what? They are the same with this column. So therefore we can conclude as P exclusive or Q is logically equivalent to what? To Q exclusive or P, still which is called commutative. So now this is all about exclusive or. Now the next thing that we are going to talk about after all this exclusive or is what you call implicative operating. And this implicative, now we are going to talk about implicative, which is in the case implicative, which we see that the symbol is represented like this, and it occurs normally in a sentence in a form of what? If then statement. Now this is how it occurs. Now let's take an example. Now say if Omar is a student then John is a governor. Right? You see, we have if Omar is a student, then John is a governor. Remember, we let Omar is a student to be P and John is a governor to be Q. Right? So now using this symbol, we now say okay, P, this if and only if this is the symbol, now say imply Q. Now this is how we represent this statement using symbol, logical symbols. So now what is the truth value of this statement? A truth value of this statement is said that an implicative statement is when P and Q are two propositions, then this relation is said to be truth if whether this has two conditions. If condition number one, if Q is what? Is true, or the second statement, or both P and Q are what? Are false. So this is only statement that this statement will be true. That the condition, these are the two conditions that will make this statement to be true. So now we can use a truth table to see whether it's true or not. Whether it's commutative. In the case of commutativity, then we have P, Q. Now P implies Q. Then we can text for what? Q implies P. Now we have, okay, true, true, false, false. We have true, false, true, false. Now remember we say that when we are checking for this if, we have to check the value of this first. Now if you check Q, here is Q. You see here is true. You just can write true. Here is also true. Write true on the column of Q. Now this is F, which is false. To check for this false, we ought to check for the P. If P is false, then all the statement will be true. But since Q is false and this is the different, meaning is false. Now when you check about, okay, the next condition is when both are false and these are false, they are all false, which is what is true. Now this is this. Then for this, we ought to check for Q, wait for P, since Q implies P. Then this is true, this is true. Then this true, false. Is this a false? No, it's true. Therefore, it's false. This is false, false is true. Now, if you check these two columns, you see that they are not the same. Why? Because true, true. Here is false, why here is true. And here is true, here is false, meaning they are different. You now say, therefore, P implies Q are not logically equivalent. Q implies P. Now, this is how we represent implicative statement. Thank you very much. In our class, we'll discuss about by implicative statement. Thank you very much.